I'm not really a fan of this single shear setup for this hanger, but that's kind of the design, so I'll have to work with it. The top of the coil-over up there is double shear, and so they use a little bit smaller bolt. Down here they went single shear just for packaging ease, and they upsized the bolt to make it stronger, so that's good. But they're using these spacers. These are little steel spacers to help keep enough room between the end link, and so you can get articulation. The problem that I foresee is that you really have to crank down on this bolt to really compress this whole stack to keep it stiff. And that may be fine for this spacer between this grade 8 nut and the steel ball link on the inside. But here you have this going into this aluminum hanger bracket. And so if you really crank down on it, this steel spacer with the very thin sharp edge is gonna bite into this aluminum, and whether it crushes in too much or not, I don't know. So what I think I'm gonna do is go in and remake 2 spacers, one for this side, one for that side over there, to replace this, that will have a taper to it to help distribute some of the forces going into this aluminum piece. All right, so I drew up the bushing quick, not to scale, just to do a little calculation. Looks like I need about a 21-degree angle when I cut that taper, and so I am going to attempt to set up my compound there on the lathe to give me that 21 degree, and then I should just keep whacking away at it until the minimum diameter gets down to 0.715, which is the outer diameter of the current bushing. And I got a piece of 1 inch in there, and it's been faced and center drilled on the end, and I've got my compound set to 21 degrees right there. And so what I'm going to do now is I'm going to make the cut using the compound. It'll kind of move like this, and then I'll advance the cut by using the cross feed. And I know that I need to get 0.1425 in, and so I can use my dial gauge to get me close, and then I can start measuring. And then I've locked the carriage lock right here, so that ain't moving. So I've never done any taper cutting on this, so we'll see how it goes. That went pretty well. I think I got right in the dimension I wanted. It's the right diameter here, it's the right length. So what I'm going to do now is just take a skim to take this the scale off of here, and then I'm going to come back and drill out this hole to the 5/8 size that that bolt is, and then I'm going to come in with a part off cut and just plunge cut straight into the cut, and then this should pop right off, and then I get to make another one for the other side. And I'm being a little bit greedy, and I'm just going ahead and using a 5/8 bit, and so hopefully it won't bite me by making the clearance too high. But I've got it in a real low speed. I've got the lathe in back gears so that hopefully I will not get screwed by my decision not to creep up on this. So I'll just give you a shot of how slow the lathe is actually running right now. All right, I'm all set up to part it off. Basically got the inside edge of the parting tool set 0.375 back from this edge. I brought this face of the tool holder up against the squared off face of this so that the parting tool will cut straight in. I've got my compound set at 0 degrees here, or 90 degrees, so that it will, actually I think that's 0. So as it pushes in, it won't cause the compound to move and cut in a cone fashion. It really helps, especially when you're doing a parting off tool on steel, to get it as stiff as possible. So I've only got just enough out. And then I've also got the carriage locked. So we'll see. Thus, having verified the laws of trigonometry, once again, We have the new part and the original. You can see this face is the same here as there. That's the face that's up against the steel insert on the end link. So that's all good, but you can tell the tapered profile. And if I flip it over, you'll see that this face has got a lot more surface area, so it won't gouge into that aluminum shock hanger. All right, there she is in the car. The piece I made is on the left. One of the stock ones is on the right. And those of you with sharp eyes might notice something a little wonky. This stock thin-walled bushing has gone barrel shaped. And this is because, again, it's back to the bad directions from Speed Track, or the lack of instructions. There are no torque values in any of their instructions, at least for the rear. And so, you know, the spec torque value for a grade 8 5/8 fine thread bolt is 180 foot-pounds. So knowing that these single shear setups are sensitive to the amount of crush you have as to the amount of strength you have in bending, I went with a conservative 100 foot-pounds. And before I even got there, I started flaring out this spacer. So luckily I have 2 extra ones because I've replaced these. Now obviously this chunky beast right here didn't flare, so it's fine. So I'm gonna go back and try it again, maybe with 75 foot-pounds, and hopefully we get there without crushing another one, because I've only got an extra one after this. So anyways, but I'm gonna get these torqued down and call it a day. All right, there's the comparison between the one that I squashed on the left and the non-squashed one on the right. I sacrificed another bushing for everyone out there who's putting one of these Speed Tech frames on. I started barrel shaping the bearing here right at 70 foot-pounds. And so I would keep it at 65. So you want obviously that to be as tight as you can because of that whole single shear thing. But to be safe, 65 foot-pounds, no more, and you won't squash these little spacers. So there's your PSA.